Okay, so Stokes theorem. So in this section, we will discuss generalization of Green's theorem. Now, I will define what is Green's theorem. So let us recall Green's theorem. So Green's theorem is the integral over C. Okay, I am only considering the work integral, or we can write f of xy dx plus g of xy dy, or this is actually f dot dr. Okay, this is equal to double integral over r dou g by dou x minus dou f by dou y dA, where this C must be a curve, simple closed curve, and this C is in the plane. Okay, two-dimensional plane. Then we can find a work integral or double integral or line integral by using double integral, and we can easily find the answer by using Green's theorem. Okay, so now what we will do is this Stokes theorem will also provide us a physical interpretation of curl. Now we will also study the application of curl of a vector field in this theorem. And this theorem is a generalization of Green's theorem. Now suppose what our surface sigma, I am calling this sigma, oriented surface sigma, is bounded by a simple closed curve C. That means this is our surface sigma, and this is oriented by a simple closed curve C. That is, this is C. Okay. Simple closed curve C. Now, now there will be two as we have case like positive direction and negative direction, that is positive orientation or negative orientation. Similarly, in a surface in the boundary three-dimensional case, there will be positive and negative direction. So first I will define what is positive direction of C. The positive direction of C relative to the orientation of S is, that means if a person is walking through the boundary, if the uh, surface is on the left side of the person, here this person is walking like this and the surface is on the left side of the person, then we say that it is positive direction of C. That means if a person is walking through the boundary of the surface and the surface is on the left side of the person, then we say that C is in positive orientation or positive direction, and the negative direction of sigma C relative to orientation of sigma is if a person walks through the surface or through the boundary C, if the surface is on its right side, here surface is on the right side of the person, then the orientation is negative. Okay, negative orientation or upward negative norm. Now we will define what is recall, what is curl of a vector field. So if f of xyz equal to f of xyz I plus g of xyz j plus h of xyz k, then curl f is this, that is determinant of ijk dou x dou y dou x by dou x dou y and dou y dou z h f f g h. So that is actually del cross f. Curl f is del cross. Now we will move to Stokes theorem, and I am only giving the work integral, Stokes theorem, to calculate work integral. So there is some theorem statement is there. You can study that statement from the notes. So I will only give you the work integral. So Stokes theorem tells us integral over C f dot dr is equal to double integral over sigma curl f dot n ds. Remember one thing, C is what is C? C is in three-dimensional boundary of a three-dimensional surface. Okay. Then in double integral over C f dot dr is double integral over sigma f curl f dot n ds. So now we will do a problem. Okay. So remember one thing, the find work done performed by a force field on a particle, that is f is x square I plus 4xy cube j plus y square x k, on a particle that transfers the rectangle in the plane z equal to y. That means this is something, a boundary of a surface. Then only work integral we will use Stokes theorem. If it is in plane, we will use Green's theorem. So that is important. Here, the rectangle is the boundary of the surface. And I will. So this is the figure. And here, look at here. This is the direction. So if a person walks through this direction, it is on the right side, right? So this is negative orientation. So in this figure, the orientation is given as negative. Now we want to calculate work integral. Okay, so we can do it together. So let given f of x y z. Okay, so this is our force field, x square I plus 4xy cube j plus y square x k. So anybody have any doubt? So this is the given vector field. Now what we will do is, okay, so we have to find out the work done. Then we know that work done. What is the formula for work done? Work done by a force field. Anybody? Integral over, it's line integral, right? Integral over C f dot dr. So this is work done. Now by Stokes theorem, tell me what is Stokes theorem? Stokes theorem. So this is Stokes theorem. What is the integral over C f dot dr is double integral over sigma curl f dot n ds. So this surface integral curl f dot n ds. Okay. Now, so this is w equal to integral over C f dot dr is equal to double integral over sigma curl f dot n ds. Now first our aim, first we have to find out curl f, and please find curl f. What is the formula for finding curl f? Anybody? Anybody? So first we have to find out curl f, then we have to find out n ds norm. So what is curl f? I j k, right? This is dou by dou x, dou by dou y, and dou by dou z. What is here? X square 4 xy cube y square x. So if you find the integral I times So we are cutting this to dou by dou y of y square x. What is 2xy, right? Minus dou by dou x of 4xy cube. That is 4y cube plus, sorry, minus j times dou by dou x of y square x. So that is y square minus dou by dou z of x square. That is 0 plus k times dou by dou x of 4x cube xy cube. So 4y cube. There is, I think I made a mistake, right? What do you mean?
Sir, dou by dou z of 4xy.
Dou by, okay, here, okay, here, right? Okay, 0. So this is minus 0, and here it's correct here. And last one is dou by dou x of 4xy cube is 4y cube, right? Minus dou by dou y of 0. Yeah. So therefore 2xyi minus y square j plus 4y cube k. Is it correct? LF is correct.
Sir,
Okay. So now therefore here therefore curl F is equal to 2xyi minus y square j 2xyi minus y square j plus 4y cube k plus 4y cube k. Now tell me what is the normal here. So here we have given z equal to y and the orientation is negative. So given z equal to g of xy equal to y. Now tell me, and oriented downward or negative direction. Now tell me what is n or sorry, we can find integral. I will write dn ds is equal to double integral over r curl. This I can write curl is 2xyi minus y square j plus 4y cube j dot, what is orientation? Orientation is downward. Then what is nds dot, is it my it minus ആണോ plus ആണോ? Is it minus or plus? Negative orientation dou z by I plus dou z by dou y j. Here minus k, right? The formula T. If it is positive, then here minus dou z by dou x I minus dou z by dou z k j plus k. That means what we use is there is a simple idea. This is z, right? If it is positive, then what is our z coordinate? K. K is positive. If it is negative or downward, k is negative. Okay. Now tell me what is dou z by dou z by dou x 0. Dou z by dou y
1.
1. Okay. So now we can write this double integral over R 2xyi minus y square j plus 4y cube k dot dou z by dou x is 0 I plus j minus k. Now tell me what is its dot product. This becomes 0, right? Tell me what is dot product minus y square minus 4y cube. Is it correct? 2xy dot 0 0 minus y square dot j j dot j minus y square plus 4y cube minus k dot k, that is 4y cube. Is it correct?
Yes, sir.
Okay. Now we want to find the projection of this on the xy plane. Okay. So and here it is given right, here it is 1 3, right? X ranges from 0 to 1, and if I get a projection here, this is our R. Here it is 3, right? So here in on the xy plane you will get x ranges from 0 to 1, y ranges from 0 to 3. Anything y ranges from 0 to 3. So examining figure തരൂല, they may be give the surface itself. Here from the figure 0 to 1 and 0 to 3. So our region is 0 to 1. So this is our region R. Now tell me what will be the limit. X ranges from
0 to 1.
0 to 1 and y ranges from 0 to 3. So this is integral 0 to 1, 0 to 3 minus y square minus 4y cube dy dx. And tell me the answer. You just calculate the answer. I will show you the answer from the discussion so that we can check. So this is solved in textbook. Okay, so that is correct, right? If you calculate this, you will get answer is minus 90. So the answer is minus 90. Minus 90. Okay. So in this manner, we will find work in it. Any doubt? So the one of the thing is this here we have given the surface, and from the surface we have to find R. Okay. Now we will do one more problem. I think I will give you an hint, and you should do this by yours. So here the question is verify Stokes theorem for a vector field f of x y z is equal to 2zi plus 3xj plus 5yk, where sigma to be the portion of the paraboloid for which z greater than or equal to 0 with upward orientation and C be the positively oriented circle x square plus y square is equal to 4 that forms the boundary of sigma in xy plane. Okay. So here we can use Green's theorem, direct method. That will be very easy. So, uh, so here our surface is C is actually this x square plus y square is equal to 4. That is C, right? Now we will do it in on the direct method, and we cannot use Green's theorem because it's in 3-dimensional space. But what we have to do is we can do by using direct method, and we will verify. The question is to verify Stokes theorem. So first we will find line integral, and then we will find by using uh, Stokes theorem. So how to do the direct problem? So what is f? F is 2zi plus 3xj plus 5yk. And tell me what is the parameterization of circle. So here we have given r of t is equal to a circle, right? What is x square plus y square is equal to 4. How to parameterize? X equal to
R cos
R
theta.
cos theta.
cos theta. So r is here
2.
2. So our x term is 2 cos theta I plus what is y term? 2
2
sin
sin
theta.
theta.
And theta ranges from I'm putting r of theta 2 pi. Now I want to find out integral over c f dot dr, which is equal to integral over c. I will calculate. Okay, integral over c f is 2zi plus 3xj plus 5yk and I don't 5yk dot dr. Dr is dxi plus dyj plus dz. Okay. So this is this part we studied in our first module. So integral over c 2z dx plus 3x dy plus 5y dz. Okay. Now what we will do is okay. So already we have x equal to 2 cos theta. Then dx is minus 2 sin theta. Y is 2 sin theta. Dy is 2 cos theta d theta. Okay, so here d theta, here d theta. And z is, there is no term in z in the figure because z is 0. Then dz is equal to 0. So now we can write this is integral plus 0j 0k integral 0 to 2 pi 2 into what is z is
0.
0, right? So z is 0 plus into dx is minus 2 sin theta d theta plus 3 into what is x is
2 cos theta.
2 cos theta into dy is again 2 cos theta, right? 2 cos theta plus 5 into y is 2 sin theta and what is dz 0, right? So this is actually equal to integral 0 to 2 pi. This is 0 and this quantity becomes 0, therefore 6 into 6 is 12 cos square theta d theta. Okay. So now you integrate this and okay, integration is easy, so I'm just using we can just check in the textbook what will be the answer. So the answer is very from okay 12 cos square theta d theta is 12 pi. Answer is 12 pi. So you will get the answer 12 pi. 12 pi will be the answer. Now you do the problem, the same problem by using Stokes theorem. So I will give you hint Stokes theorem. So Stokes theorem is integral over C f dot dr, which is equal to double integral over sigma curl f dot n ds. So first you find out curl f. F is given, so you can find curl f. Curl f. You find curl f. Then also we have given this is positively oriented. That means orientation is up. And z is given as 4 minus x square minus y square. Z equal to 4 minus x square minus y square. Then you can find dou dz, dou z by dou y, or minus 2x minus 2y. And this integral you will get integral over r curl f dot, it is oriented upward, so this is formula minus dou z by dou xi minus dou z by dou yj, and we know that it's oriented up, therefore k positive k. So now you find this and you will get the same answer. Okay.